Hello, everybody. This is Brett speaking. As you could see from that absolutely killer introduction, we're going to be talking about virtual reality and augmented reality as it pertains to aircraft maintenance practices. Gabe and Armando were my group members. And all right, let's dive into it. I think Gabe's going to lead us off here.
So first, I'd like to talk about a little bit of the background of why this might be a necessary thing or an important thing for the future of aviation. And the first basic point here is that on-the-job training might not expose you enough, and that's current on-the-job training. And what I mean by that is that you cannot run into every type of plane or every type of part or every type of engine or every type of fault or failure or error. You're only exposed to what you get exposed to in your training, and then you get exposed to more as you work. But um, computer training and AR and VR might be able to get get us more exposure in these areas early on in our careers. Um, Kind of ties into my second point here. May also be expensive and space consuming. Kind of just is expensive and space consuming. We've all dealt with this. We all go to college here, and we all used to go to the labs, and we've had issues with the space in those labs, and it goes back to having to keep all these all your engines physically there, and so that's all you get to work on, and that's all you have the space for. And then the big fact there, that in 2003, maintenance mistakes were blamed for 42% of aircraft fatalities. Aircraft inspections a necessary and important part in ensuring the safety of your transportation. Early detection and correction of defects in the aircraft is essential to prevent accidents. So making mistakes that were almost 50% of the crash, making mistakes on the ground before the aircraft even flies, it can almost seem unacceptable at times. Um, and then I'll touch on a little bit about just that computer-based training may cover some of these gaps, but it's not always reliable enough, and so that's more like a sit down on a computer, and yes, it's like a simulated reality, and it has the added benefits of being able to customize it and stuff, but like there are plenty of articles about how that kind of education and training isn't necessarily the best. It's not immersive. It doesn't make you feel like you're really doing it, kind of thing. And that's more or less ish, why AR VR might be the future here. So I'd like to talk about a little bit of background of just VR in general. So to start, kind of the very first thing that's you could attribute to the development of VR was the ViewMaster back in 1939. And I'm sure all of you have heard of this, and I'm sure most of you have used one. Those things you just put up to your eyes and had these little thin cardboard discs that could have up to like 7 photos, and they were like these 3D photos, and you'd spin them. You'd see things like the Eiffel Tower or Mount Everest or whatever you wanted. They made a bunch of them, and that was a huge deal back then, as you could see all these places in 3D and not actually be there, and it was very popular with kids. Still is at some degree. And then later down the line, 1960, a guy named Morton Hellig invented the Telesphere mask, which was kind of the first head-mounted display that actually attached and strapped around the back of your head. It was non-interactive still, like you didn't get to move your head around and it panned or use your hands and interact with things. But it was a head-mounted display, and it was much more realistic 3D, and it was kind of the first thing that when you looked into it, kind of looked like what we look at today. And then all the way down in 1990, we have NASA's Virtual Interface Environment Workstation, or VIEW. Um, this is kind of the biggest first full VR as of what it is as what VR is known today. It's a head-mounted display works with an artificially computer-generated system or a real environment system relayed from remote cameras. You can actually interact with it with those. She has some gloves on with some wires and stuff. Those actually are called the data glove. They have fiber optic cables and sensors, and they transmit the motions of the fingers and hands to the computer, and that's simulated in the computer in the virtual environment for you to see. And if it's like a completely artificial, or you put something in there, you can interact with whatever it is. There is also, she's not quite wearing it there, I don't think, maybe underneath her jacket, you can't see it, but there's a data suit as well. It's a full body garment that greatly increases the sphere of performance in your virtual reality simulation. Obviously, tracks your motion of your whole body a lot better rather than just placing your body based on where your hands are. And that was, like I said, kind of like the biggest first step into what we know as VR today. And there was a lot of stuff in between all this as well, but these were kind of like the big first steps into VR. So next I'd like to talk a little bit about why VR should be incorporated in the future of our aircraft maintenance training. And my first biggest point here is the customizable simulation. And now I already kind of talked about that back in the background, but that's the thing that you don't necessarily get exposed to even a large portion of what you might experience in the field, in our field, and in your careers. You only have what's available to you in your resources. We only have what's here at Purdue and what we get through our courses. Whereas with VR, you can place yourself in any scenario imaginable. Any kind of problem you need to look at and fix, any kind of error, any kind of defect or repair, you can place yourself in a situation to work on that and to be there with that. And that's a very valuable resource to have. Next thing, it's incredibly safe. A private automotive OEM had a virtual manufacturing technology company design them a safe and efficient work environment. They tested their immersive VR, and along with that and a couple other new safety regulations, they reduced their employee injury rate by 70%. And that's a big deal. In our field, injuries are serious. They can be life-threatening and otherwise permanently defecting, and at the very least, taking time off for injuries is never what you want. No one wants to get hurt on the job. And this is an effective way, especially when you're learning, to maybe not hurt yourselves with things that are dangerous. Next point here is the low relative cost, and as you can see there, it says the startup cost is the biggest hurdle, and that's true. The startup cost is definitely the biggest hurdle of anything like this, and the maintenance cost for this is relatively low. You need to obviously have the computers, and even now VR is catering to the point where it can be on its own, separate from computers, so who knows in a couple years what that might be like. But you just need your memory, and then your VR and your power, and yes, there's a lot of upkeep costs for that, but as a university, looking at some of the things they upkeep now, it would definitely be relatively low, and the startup cost would be the only thing that's maybe an issue. And then the final point, and maybe the second biggest point in the whole list, is the immediate feedback you can receive from this type of training. So it's estimated that in terms of traditional CATIA and DMU methods, something like a VR test can be 25% faster to perform your verification and validation activities. That's quite a lot faster, and it makes sense. And if you think about it, again, it goes back to everything. Kind of goes back to this, but the customizable simulation. Put yourself at any step along in the process. It lets you know immediately that it's not working or you're doing it wrong. You don't have to keep going on doing other steps before you figure out that you've done something wrong and then have to undo all your steps and do all of that again. It would keep you on the current step until you've got it right. So that's much more efficient in that manner. And then I've got their A&P question mark. And I read an article about this, and I'm not definitely not suggesting that that VR is used exclusively for your AAP, and I'm not even suggesting that VR is used exclusively for training. I think that hands-on training is always going to be a thing, and it has to always be a thing. Just that VR could definitely help in conjunction with it. And again, with the AMP, I think it could very much help with conjunction with it, and that's what this article kind of was talking about, is that some of those things where they don't have you necessarily do them, they just have you talk them out because you don't have the physical way of doing it, or it's much too time consuming where you're at. Either way, you can now do it in VR. You can now customize that experience, have all these things set up prior to your AMP test, and then come in and all the things he doesn't have you do physically, or not even all of them, just certain things, he could have you do in VR and see that you know how to do it better than just you know how to explain it. And that probably would be easier for us too, rather than sitting there trying to just explain it off the top of our heads. You could see it. You could do it with your hands in a sense.
Alrighty, so we're gonna go ahead and talk about augmented reality versus virtual reality and kind of what the difference is. And there's a important distinction. Augmented reality is defined as elements that are superimposed onto the world that is around, and this is done with either goggles or tablets, as you'll see in the videos after. And virtual reality is a 100% synthesized environment, whereas what you're looking at is 100% fake. We'll go ahead and talk about both and what the benefits and drawbacks are. So if we roll into this first video here, you'll notice that this is an example of augmented reality. Now, augmented reality, like I said, you're looking at something real with superimposed images of things that aren't. An example here is this aircraft. You can see its internal power plant and how air is delivered into it, basically how it functions. This is really useful, especially if you're just undergoing standard maintenance practices. If you look at the video that's being shown, if you have the capacity to look at an aircraft and see what's on the inside, it makes it a lot easier to conceptualize. And I think that's kind of what we struggle with when we look inside manuals. It's very difficult to see something on paper and then try to kind of guess as to where it is and what it looks like inside the aircraft. But with augmented reality, it's a lot easier. So easy, in fact, that you could literally just walk up to the aircraft and be like, yep, there's the turbine. There's the stator, there's the fuel delivery system. Anything you need is basically superimposed. That, I will say, is one of the more difficult parts of the development inside of the virtual reality and augmented reality world, because not only do you have to track where images are, but you have to have software that'll constantly keep updating as to your location on the aircraft and where things are in the aircraft. Moving on to the next video, you see this is virtual reality. This is essentially maintenance from a desk, and it's used essentially in training, or will be used, which we'll talk about a bit more. The benefits of this is that, once again, you can conceptualize aspects of the aircraft because, like I said, it's not easy to see on paper, and it's not easy to read through a textbook always and just understand a two-dimensional diagram of a hydraulic system and then try to take a gander as to where that is in the actual aircraft. Whereas here, you can literally crack open the nacelle and take a look at the power plant and other parts whenever you need. This is actually, ironically enough, a 100% synthesized environment is a lot easier to create and go ahead and build. Because you don't have any real aspects on the aircraft. So it's not like augmented reality where I can walk up and conceptualize things. It's all fake. I could sit there and I could walk around this pretend aircraft. And, moreover, it makes training a lot easier, as I said. We'll talk about why this is important here in a few, but it's important to denote the difference between the two because there is quite a big difference.
So during an aircraft design and development phase, or when modifications or updates are implemented, Airbus engineers apparently need to check and improve the feasibility of related maintenance activities. The aim is to support high levels of operational reliability, and minimize direct maintenance costs from airlines. This has generally been done with traditional digital technologies such as CATIA and DMU, which is a digital mockup. Depending on the situation, physical verification also can be performed on the aircraft for more complicated items and processes at a later phase in the development. The downsides of these traditional verification methods are that their requirements in cost, time, and engineers' experience. Because of VR being, it's kind of new, it's still, there's not a whole lot of people that have the experience with VR. In 2019, the U.S. Air Force launched a pilot training course called Pilot Training Next. It's for 30 students. This one uses VR headsets and advanced AI biometrics instead of the multi-million-dollar flight simulators. With this, 13 pilots were certified in just 4 months. The usual pilot training system takes about a year. The VR flight training cost came in at $1,000 per unit instead of the usual cost of $4.5 million for a legacy simulator. Students were able to fully immerse themselves in a cockpit using a HTC Vive virtual reality headsets, which is, I believe, one of the first virtual reality headsets that came out as well. This one has biometric monitor heart rate and pupil measurements, giving flight instructors an accurate reading of just how immersed students were in the learning experience, something not possible with the traditional flight simulator. So I'm going to talk about the current development of VR in the aviation industry. So let's start off with Airbus. So Airbus is coming up with the best way to maintain, repair, or replace an aircraft component in a crowded or tight environment. With them being one of the biggest aircraft manufacturers, they would like to have more reliable, futuristic ways to work on parts like avionic components or something bigger like an engine pylon. Airbus states that with digital technologies, working will be as easy as putting on a pair of virtual reality glasses, apparently. Um, they also state that virtual reality, or VR, brings real benefits and value, making it possible to stimulate and reproduce situations in a safe environment that would otherwise be costly, complex, or even dangerous. In recent years, virtual and augmented reality have become more mobile and easier to use than ever, creating the potential to completely transform many areas of business. Um, with this said, on the side, I kind of emailed a Airbus recruiter from Germany, and I asked the recruiter how it was to work a day at Airbus with the VR technology that they mentioned they have. If they had some type of video that they can't share with me or anything. Apparently, this VR is still kind of a R&D, but they have implemented it already in their like day-to-day um, work. Apparently, that's what they state on their website. This recruiter who I tried getting information out of was pretty much useless. I asked him, can you send me a video or just answer a couple questions, and all he can reply back was, Airbus has been a big supporter of virtual and augmented reality technologies in the industry, implementing VR software tools throughout the aircraft design process. They have also implemented VR software on the digital shop floor and for inspection purposes. Um, this might seem like a kind of solid response, right? This person literally copy and pasted what Airbus had stated online on literally the resource that I'm using for this.
So, lastly, I really want to talk about why this is actually helpful in the end. As some of you graduating seniors or those of you getting really close know, if something like this could be accepted into Part 147, where you could literally sit inside your room and basically drop into an aircraft hangar and begin to sort of work on labs and take apart different aspects of the aircraft. That is incredibly useful. I know this COVID-19 thing has set us all back quite a bit. if not in your own graduation schedule, then just more so on your skill on how to correctly maintain an aircraft. So, like Armando said, this is definitely a few years down the road. We're not quite there yet, but if something like this could be refined and perfected to a point where the FAA would allow it to be taken into Part 147, not only would you save money through actually having these power plants and these avionics and these hydraulic systems on hand, because you don't need them anymore. You would essentially just have them in whatever software you decided to run. As for this presentation, that's really all we got. I have an itching suspicion that the audio won't work during the presentation, but if it did, I hope you all enjoyed. And if you have any questions, I guess we could take them now, and we'll just go ahead and drop them in the chat. And so if you have any questions, just shoot them our way now.